quick recap of Friday's notes where we talked about how to find how many subsets a set has. There were two major walkaways I was concerned about. The first was that everyone know that the empty set is always a subset of any set, and the set itself is also always a subset of any set. And then we discussed like a process for finding all possible subsets. So what we did was I gave you guys a set A that had 2 elements, a set B that had 3 elements, a set C that had 4 elements, and I asked you guys to find all the different subsets. Now when it's just 2 elements, you guys could probably piece this together yourselves. There's not a lot to keep track of here. One thing that came out in class was that AB is a subset, but making another set that's BA is not a separate subset. It's the same thing, so we don't count that twice. When it gets to be 3 elements and 4 elements, listing all possible subsets can be much more of a challenge, and so let me start with the most complicated of them all, the one that's with 4 subsets, and I'll explain how I would go through this in an organized approach. If I wanted to list all possible subsets of a 4-element set, the first thing I would do is list all possible subsets that have just 1 element. That's pretty easy to do. You're just going to go ahead and pick each element of the set and make it its own subset. So this would be considered a subset of set C. This is a subset of C. This is a subset of C. This is a subset of C. And these are obviously all of the subsets of C that have just 1 element. When we go on to 2 elements, it gets a little more tricky. So just keep yourself focused. What I like to do is start with start with that first letter and then pair it with everything else in the set. So you'll see I started with A and went to B. Then I went from A, C, that was this subset. Then A, D, that was this subset. Now that I've paired A with everything, I'm going to move on to B and pair B with everything. I'm not going to pair B back with A because I already took care of that one. I'll go from B to C. That would be a subset. B to D. That would be a subset. That's everything new that I could pair with B. I'll move on to C and pair anything new with C, and that just gives me C and D. So I'm confident that this line consists of all the elements, all of the subsets of C that have just 2 elements. And now I got to go on and do the same thing but have 3 elements. So I'll do the same thing. I'll start with the first 3 elements, A, B, and C. And this time I'll keep the first 2 things consistent as long as I can. So I'll mark AB with C, and then I'll do AB with D. So once I've hit these 2, I've found all the subsets that start with AB. Let me keep A the same, and I'll organize A with C and D. And then finally, I can move off of A and say the last one is B, C, D. So the idea is to keep as much constant as you can, always changing the later ones as you go through. This is all the ones that have 3 elements. Then we still have to look at the one that has 4 elements, and that's the subset A, B, C, D. This last one is definitely considered a subset of C because everything that's in here is also in C. Like any element I can pick out of this set is an element of C, but this is not a proper subset because a proper subset would have to actually have fewer elements in the set itself. Everything else that I wrote down here is a proper subset. Proper subset means, like for example, this is a proper subset, ABD is a proper subset, because everything that's in this little subset is definitely in C, but it also has fewer elements. So really, every subset is a proper subset, except for the one that you write down that's exactly equal to the set itself. That's just considered a subset, not a proper subset. And of course, the empty set is also always considered a subset, because there isn't anything in here that I can't find in here. Even though there's nothing in it, everything in here, which is nothing, is also in here. So we did some stuff like that. But the real goal of this assignment was to have students look at when there's 2 elements, when there's 3 elements, when there's 4 elements, how many subsets do we have, how many proper subsets do we have, and we noticed a pattern. So when there were 2 elements, we found, and you should do this yourself if you weren't quite picking up on it when we were doing it in class, try this again yourself. List all the subsets of things with 2 elements. And you'll find if there's 2 elements, there's 4 subsets. When there are 3 elements, there were 8 subsets. When there were 4 elements, there were 16 subsets. So we started looking at a table where on this side I wrote how many elements were in the set. And you'll notice we didn't even do number 5. Like we didn't do 5 elements in a set. So this column represents how many elements are in the set. And then we wrote down how many subsets each thing had. So when there was 2 elements, we found there were 4 subsets. 3 elements gave 8, 4 gave 16, and we asked the class, Okay, so if it's going 2, 4, 8, 16, what do you suspect is true for 5 elements? And people thought 32. They noticed a doubling pattern. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so on and so forth. So that is correct. If there were 5 elements in a set and we try to list every single subset, we would have 32 subsets. I'm never going to ask you to list all 32 subsets. That is crazy. But I do want you guys to be aware of this formula, which is if I'm asking you how many subsets a set has, and I tell you how many elements that has, then you're going to use 2 as the base and the number of elements as the power. So for example, if I wanted to figure out how many subsets a set had if it had 6 elements, I'd be taking 2 to the 6th power. Not 6 to the 2nd power. That's a mistake people make. 2 is the base and the number of elements is the power. That's what this formula says. If you have n elements in your set, then 2 to the nth power is how many subsets you have. And then if we wanted to talk proper subsets, every single subset's a proper subset except the one subset that is the actual set itself. Like in this one, when I had set B equal to ABC, this ABC is a subset because everything that's in this is also in set B, but it's not a proper subset because it actually also equals set B. This is just the only one. This is the only one that's not proper. This is the only one that's not proper. This is the only one that's not proper. So if I'm asking for number of proper subsets, you're going to go ahead and take, if it's 4 elements, you're going to take 2 to the 4th power and get that answer, and then subtract 1. You know, if it's 7 elements, n equals 7, then 2 to the 7th power is the number of subsets, so 128 subsets. And the number of proper subsets is 1 less than that, so 2 to the 7th minus 1. So I definitely want you guys to know these formulas, know how to use them, and understand, of course, we did a review of this notation, like what does n of a equal 2? What does this mean? What does this mean? What does this mean? So this was from previous notes, but I'm just reinforcing that. So this is a 8-minute recap of those notes. If you have questions about stuff, let me know, and good luck.